All right, for this next part, we actually already talked about plotting complex numbers. If you notice on the graph, this should have actually been down a little bit, but your real part is your x-axis and your imaginary is your y-axis. So you're going to plot all of these on your graph and label them with A, B, C, D, and E. So for A, where will I go? 3 to the right. 1, 2, 3 right, and 2 down. And make a point, and I'm going to label that as A. For B, where will I go? And then make a point, and I make that B. C, where will I go? Very good. Up 3 and label it as C. D, where will I go? Very good. And lastly, -3, -3i. Okay, so part of your homework, they're going to ask you to plot them. You can use one graph and plot all the numbers. Okay, and you could label them the same kind of way that we did here. All right. Last part here. This goes along with worksheet 4. When you're adding fractions, they need to have a what? Common denominator. Do these have a common denominator? Yes. So when you add them, I'm going to leave the denominator the same. So I have 1 plus 4i and the denominator, and then 3 plus 4 makes what? Okay, can that be my answer? Why can't that be my answer? Good. How do I get rid of the I in the denominator? Conjugate. What will my conjugate be? Okay, you guys do this one on your own. If you need help, raise your hand and I can come and help you. Otherwise, you can raise your hand and I'll check your answer. Okay, so the answer was 7 minus 28i all over 17 if you got a chance, and I didn't see yours. Okay, so when I multiply this denominator, I make my box, and I have 1 and 4i, and 1 and negative 4i. When you multiply, 1 times 1 makes 1, 1 and negative 4i makes negative 4i, 4i and 1 makes 4i, and this is where you have to be careful. So 4i and negative 4i makes negative 16i squared, but what is I squared? So negative 16 times negative 1 ends up making a positive 16. So I'm crossing all that out, and I have 16 and 1. 4i and negative 4i cancel out, so then my denominator becomes 17. And then for the numerator, I distribute. 7 times 1 makes 7, and 7 times negative 4i is negative 28i. And can these reduce at all? No. So that's my answer. Okay. Because we had a 16 and a 1. Right? Are we good? Okay. Okay, what you need to be careful about on number 2 when you're subtracting is that this minus sign right here needs to distribute to everything on the top. This one, there only happens to be a 3. But if there was like a 3 and an I or whatever, you need to distribute it to both the terms. So for this one, I'm just going to distribute there to the 3. So that becomes negative, which then I can now change this to a positive. Because you don't actually want to subtract, you want to end up distributing it so you can add your negatives and positives together. Okay? So now, is my denominator the same? Okay? So we're going to have 1 minus I in the denominator. And on the top, what ends up happening? The 3's end up canceling and we just have 4i. And then we come to a similar problem that we've already had. So how do I get rid of the 1 minus I in the denominator? Good, we multiply the conjugate, which is 1 plus I, to the top and the bottom. I would go ahead and make a box here. So I have 1 and a negative I and 1 and a positive I. One times 1 is 1. 1 times I is I. Negative I times 1 is negative I. And negative I times I is negative I squared. But then we get a negative 1, which makes a positive 1. So that's 1, and I'm going to cross the rest of that out. I and negative I cancel out. So my denominator is 2. Yes. Oh. Okay, so now what do? Distribute. 4i times 1 is, and 4i times I is 4i squared, but that's going to end up becoming 4 times negative 1, which is a negative 4. Okay, so when I rewrite this, I'm going to write this as negative 4 plus 4i all over 2. Now, does it look like this can reduce? What you have to be careful about is that this 2 has to go into both of these. If it can only go into one of them, then you can't reduce it. So you have to divide, and you could write this as like separate fractions. Negative 4 over 2 plus 4i over 2, and then reduce them to make sure you reduce both of them. But this ends up reducing to be what? Negative 2, and these become plus 2i. So the answer is negative 2 plus 2i. Oops, I just realized I didn't. Okay. Any questions there? All right, this last part, there is more than one way of solving this. If we go through and if we have I to the first power, what does I to the first power equal? I. What does I to the second power equal? Negative 1. What do you think I to the third power is going to equal? So the I squared would be negative 1, right? And then you have one more I, so it's going to end up being negative 1i or negative I. Okay? I to the fourth, which means you're going to end up with 2i squareds, right? So you'd end up with a negative 1 times a negative 1, which makes a positive 1. So there ends up being a pattern with i's. So like if we started this over again, I to the 5th is going to end up being I. I to the 6th is going to end up being I to the 7th is going to end up being, and I to the 8th will be 1. And it keeps repeating this pattern. Okay? If you remember these 4, and you basically, what you can do is you could like divide. You could end up getting the answer for all of them. Now, I don't like remembering 4 things. I am better at remembering that I squared equals -1, because I know this one. So me personally, when I have a problem like this, I try to write it as a square. So what I mean by that is that 7, I can't write it to a square power, right? So I would write this as I times I to the 6th, because 1 and 6 makes how much? 7, okay? I can write the 6 as a square though, can't I? So I'm going to write this now as I times, and then I'm going to write this as I squared to which power? The 3rd. Because 2 times 3 is 6. And this is a square, and I know what I squared is, right? What is I squared? So then I have it as -1 to the 3rd power. Well, anytime you have a negative to an odd power, it's going to end up being what? A negative. Because 2 negatives make a positive, right? So if this was a 4, it would be a +1. But if it's a 3 or a 5 or a 7, it's going to end up being a -1. So I end up with I times -1, which makes -I. Now, the way that I told you too was 7, if you counted, 1, 2, 3, 4, 5, 6, wait a second. Yeah, 5, 6, 7. See how if I counted through the 4, I end up getting -1 as well? I told you it's a pattern. So see how this is the 7th power? 1, 2, 3, 4, 5, 6, 7. It would be -I, which is what we got. But I don't necessarily like remembering this, so I always usually do it this way. Okay. Good observation. So this is how it is. Anytime you have an odd power, your answer is going to either be an I or a -I. Anytime you have an even power, your answer is going to be 1 or -1. Okay? How do you think, doing it the way that I like to, can I write I to the 8th power as a square? How will I write I to the 8th as a square? I squared to the 4th power, because 2 times 4 makes 8, right? And what is I squared? And what is -1 to the 4th power? It'll be a +1, because anytime you have an even power, that means your negatives are going to end up canceling out. If this had been to the 5th power, it would have been a -1. Okay. Now, this would be a lot to count through, right? But because it's an odd power, we know that it's going to be I or -I, right? So I would write this as I times I to the 80th power, because that makes 81, correct? How will I write I to the 80th as a square? Good. I to the 2nd to the 40th power, because 2 times 40 makes 80. So then we always change I squared to -1, and what's -1 to the 40th power? Is it going to be a positive or a negative? Positive, because evens are going to give you a positive. So I end up with just I times 1, which makes I. I times 1 makes I. Do we understand why this is a +1? Okay. Any questions?